The lab number 1. The lab objective of this lab is to explain digital and importance digital data in context of sort, search, store, and transmit, how to plot signals, writing scripts in MATLAB, and creating and calling functions. Going through the task 1, in the context of digital signal processing, elucidate the essence and intricacies encapsulated within the term digital. So, in the context of digital processing signal, the term digital refers to the representation and manipulation of the signal using discrete values, typically in the form of binary digits. Essence of digital in DSP is discretization, quantization, and boundary representation. And intricacies of digital in DSP is precision and accuracy, sampling rate, digital processing techniques, and noise invalidity. So, going through the task 2, which is explain how does the choice between linear search and binary search in DSP applications illustrates the relationship between digital data and sorting, and what are the implications for data processing efficiency. So in DSP applications, the choice between linear search and binary search illustrates the relationship between linear data and sorting. Linear search, uh, linear search involves sequential sequentially checking each element, while binary search exploits the ordered nature of data and repeatedly dividing the search space. And the two applications are linear search and binary search. And the task 3 is in the domain of digital data, what strategies and techniques can be employed to enhance data transmission efficiency. So the strategies and techniques to enhance the data transmission efficiency is compression technology, error detection and correction, and data rate matching and multiplexing. So here is my task number 4, which I performed in MATLAB, which is this. In this task, clears the command which clears the command window in MATLAB, and t is the line creates a time vector t ranging from 0 to 1 within a step size of 0.01, and it represents the time values at which the sine wave can be sampled. F is this line sets the frequency. This line sets the frequency of sine wave, which is 1 hertz, and another is signal is equals to sine f 2 pi t. Here the sine wave signal is generated using the sine function. The frequency is multiplied with 2 pi and the time vector t. And now we plot the time vector t and signal, and here's the output of it. This is a sine wave graph. Now moving to the next task, which is also the time vector t, and the ranges from 0 to 1 with a step sign of 0.01. The frequency is 1 hertz for sine, and the signal is provided by the sine wave signal is generated using the sine function, and again the frequency is multiplied by 2 pi to convert it from hertz to radians per second, and then multiplied by the time vector t. Plot the time vector t and the signal, give them a name, give them a title, and the label x-axis, y-axis, and the axis. The axis is this one is the 0.5 to 1.5 is for the x-axis, and minus 1.5 to 1.5 is for the y-axis. And here is its output, this sine wave. This is a sine wave of this task. And now another task is task number 6, which is there is a time vector. Again, the time vector is given, which ranges from 0 to 10 within a step size of 0.01, and there sets the two frequencies of two sinusoidal signals. F1 is 10 hertz and F2 is 520 hertz. Signal 1 is it generates a sinusoidal signal within a frequency of f1 over the time vector t, and signal 2 also creates a sinusoidal wave within a frequency of f2 with 2 pi and time vector t. So plot the signal, the time vector signal 1, signal 2, and again give them a title, x label, y axis, Y label and X label. Y label represents the amplitudes and X label represents time in seconds. And the axis is, this one is for X axis and -1 to 1 is for Y axis. And here's the output. This wave is representing the plotting multiplying signals. Now going to the task number 7. Also assign the time vector which ranges from 0 to 10 and the step size of 0.01. F1 is for two sinusoidal frequencies, 10 Hz, 520 Hz. Signal 1 generates a sinusoidal signal within a frequency of F1. And now this hold on, and the signal to S2 also represent the sign vector of another frequency F2, and also we plot the signal and same as this, and this is the output of it. Now task number 7. Here is the number of random variables which we are assigned is 50, and the random variable is 9 and 1. We plot the random variable R. Draw a line from 0 to m and 0 and n to m, where m is the mean. Calculate the mean value of R, and again plot, using the plot function and hold off and title, and this is output, the mean of random uniform. The task number 9 is this. This is the task number 9. Here make a function of my min and take a vector as an input and return the minimum value of the vector. So here we give a vector x. It's usually an array, and m is my min, and we assigned my min is equals to m, and display m function min. Min value is equals to my min input vector, and min value is equals to min input vector. So the output is 1, means it selects the minimum value in it. Same as task number 10. Here it tells the make a function of my x. The same as my min, but here it goes to the value of maximum 9. In this array there is a maximum value, so it is 9. Task 11 is same as in this task we calculate the my average value. So average is 4, and task 10, in this we calculate the sort value, and the sorting value is coming in ascending order. And another task, the reverse process, as you know, it can reverse the whole array, and yes, it is reversing the whole array. Task number 12. Task number 12 is this line also creates a time vector t starting from 0 to 0.5 with an incrementing of 0.01, and x is equals to random 50 to 1 is this line generates an array x containing 50 random values and a uniform distribution between 0 and 1, and y is equals to sine 10 2 pi t. This line creates a sine wave y within a frequency of 10 hertz based on the time vector t, and subplot the whole result. Here this subplot creates a subplot grid with a row 1 and 2 columns and activates the first subplot. It then plots the random value in x stored using in the plot function. Again subplot the function y, and the result is shown. This is for subplot of x and this is for subplot of y. And the last task is this. We create a function named as win4 and assign that data values data1, data2, data3 and data4 with random values. Now create a 2x2 subplot 2 to 1 with now plot the data and name, and the resulting output is this. And the subplot function is used to create a grid of subplots within a single figure window like this. So thank you so much for watching my video.